Welcome back. In this segment, we'll show you how to specify what machining you want performed on your parts and how the machining database fulfills your requests. There are two basic pieces of information that CabinetSense needs to know when it lays out your machining. The first is, what do you want it to do? For example, do you want a dado? Do you want to drill a conformat hole? Do you want a line boring hole, etc.? So what you want to do, and the second part is how you want to do it. And that how is a subject of what we're going to talk about right now. CabinetSense uses the notion of a template, and the template is the how. So let's take a closer look. In this closet, I'm going to place a normal CabinetSense adjustable shelf. By default, an adjustable shelf will lay out shelf pinholes or line boring. It's one and the same in CabinetSense. The how is the template. If you click on the drop down, CabinetSense lists all of the different templates that it found in the machining database. When you don't specify a template, that tells CabinetSense to go to the parent item. So we were at the adjustable shelf. We're now at the cabinet. It has a machining template, which is also empty. After the cabinet, we go to the project. And here we find that the template has a definition of closets 19. And in this case, will be the how to lay out our line boring holes. So let's go take a look at the machining database. We'll take a look at the line boring section. And here is a definition for a template called closets 19. And so the rest of these fields will instruct CabinetSense how to lay out line boring for that template. The holes are 37 millimeters from the front, 37 millimeters from the back, as well as a third set of holes, 268 millimeters from the back. And then we have spacings from the top and from the bottom, and a host of other information. There are 4 templates defined for line boring: closets 16 for a 16 millimeter closet system, 19 millimeter closet system, a default template, and a gun template. Let's go back. And before we machine it, let me just take the color off the cabinets. Let's get rid of the template. So now there are no templates defined. And in this case, what happens is the shelf looks to the parent looks to the project, and the project, again having no template defined, as a last resort, will use a template called default, right, as defined right here. It will have 3 holes, 5 millimeters, 50 millimeters from the front, 50 millimeters from the back. As well, this is a spacing algorithm to basically lay out the holes evenly in relation to the up and down movement of the shelf. So let's go ahead and preview the holes. And there are our 3 holes. Taking our tape measure, let's turn metric on. So 52 millimeters, which is different from the 50 millimeters that the machining database has specified. So what's happening? In CabinetSense, line boring holes or shelf pin holes are laid out in relation to the shelf. So from the front of the shelf, it's 50 millimeters. From the back of the shelf, there, 50 millimeters. Okay, so let's go ahead and we'll just remove the 2mm inset on the shelf. Re-preview. And now our shelf front is the same as our end front, and so it's 50mm from both reference points. Okay, so let's go back to our scenario where we had closets 19 and re-preview again. Our machining database for closets 19 had laid out 3 holes for our line boring, but we're only seeing 2. And so what's actually happening is that from the back, we have our 37mm hole, and our second hole from the back is 268, which, if you remember, is what we specified in our machining database. That same hole is also 37mm from the front. So the 2 holes are overlaying it. And we did this so that if we change the depth of our cabinet, and re-preview, we end up with the 3 holes. And so this middle hole now will be used to hang our closet rods and such things. Okay, so let's just delve a little bit more into templates and then we'll move on to the next topic. So right now, closets 19 is defined at the project level. Let's go back to the cabinet level and let's put in a gun. If you remember, we also have a gun template. And the difference here is only 2 holes, 50mm from the front, 50mm from the back, and our spacing top and bottom are a little bit different. And so now, again, the shelf deferred to the parent. It found that the parent is saying use a gun template, and so it fulfilled that request using that particular template. And the template that's defined on the project was ignored. Let's go back and do one more. Let's change gun to something called Legger box, which is really for a drawer system. Let's go ahead and re-preview. And in this case, because it did not find a template, looking at the machining database, there's no template for Legger box defined for line boring. So when it reached the cabinet and found Legger box, it didn't find any specification. So again, it just ignored it and went to the project. One other special thing that you can do, if I go to the shelf, I can specify a template called none. And none is not really a template at all. It's simply a directive that says suppress any machining that you would normally do for this part. So go ahead and re-preview, and nothing shows up. So that is one way for you to suppress machining when you don't want it. By now you should have a pretty good handle on how templates work in Cabinet Sense. So let's concentrate more on specifically how we handle line boring for our closet system. We'll go back to the standard closet depth that I'm using in this example, which is 305mm. And once again, let's just preview to make sure it's what we want. Okay, perfect. So what we really want to do is have an adjustable shelf that defines the line boring for every closet. And so what I've actually done in every closet subcomponent is there is a hidden adjustable shelf. So right now I'm going to create, a couple of them. I'm going to hide this guy, and I do that by going to the parts and turning visibility off. I'm just going to show you what happens if you have multiple machining requests on the same kind of item. So in this one, I'm going to turn on the gun template. Now remember, the visible item has no template defined, so it's going to pick up the closets 19 as defined on the project component. We now have a mixture of the two templates. We have from our front 37 millimeters and another one at 50 millimeters. So Cabinet Sense, if you have multiple templates on your adjustable shelves, it will machine all of them. So in this case, we really want to turn off all machining on subsequent adjustable shelves. And it's back to what we want. If you look in the closet example or sample library, and if you pick up the adjustable shelf and throw it into the closet, note that the template has already been defined as none. So as long as you're using the closet library components, you won't run into any issues. For the rest of this segment, we'll use a normal closet component and look at the machining for fixed shelves and drawers and doors. Before we go any further though, let's review the project component and what role it plays in our System 32 build. So in our construction settings, we're going to turn on 32 millimeter system so that we can be assured that our fixed shelves and everything is referenced off of a 32 millimeter standard. If we use a thickness of material that's different than what we set up our line boring for, we want to enter our nominal thickness at this point. So I've got it set at 19, and the material thickness that I'm using is actually 3/4 of an inch or 19.1 millimeters. So let's just go back to our line boring. And closets 19 is set up to be actually a 19 millimeter line boring. And we can tell that from what we set our top and bottom spacing from. So the sum of this should be our nominal thickness. The other thing we want to do in our closets is set our frameless overlay at half. And the reason is this guarantees that our spacing, the way that we measure our reveals for our doors and drawer fronts, will be constant from halfway or half the thickness of the material. As I mentioned before, we have an adjustable shelf that is hidden in each subcomponent, and that does our line boring for us. We'll just turn on hidden geometry for a second. And if you look down below, here is our hidden shelf. All other adjustable shelves are set to have a template of none, so that they do not interfere with the line boring that we really want. Let's move on to fixed shelves. We are using a Rayfix connector on both the left and right sides. And again, there's no template selected, so we're defaulting to the closets 19. So let's go take a look at the machining database. We'll find the Rayfix connectors defined in our Mechanical Fasteners tab. And we'll look for a closets 19 and for a Rayfix connector. Our definition for the Rayfix, we will put our first Rayfix at 37 millimeters from the front, our last one 37 millimeters from the end, again matching what our line boring setup is. The connector we're going to use is Rayfix. We have a choice of several different cam lock connectors to choose from, and you can define your own as well. We will place as I said, our first connector 37 millimeters from the front, our last one 37 from the back, and if our center to center holes has a space more than 400 millimeters, we will drill another Rayfix connector, and as many as we need to keep our center to center points 400 millimeters or less. And again, you can change this to be whatever pattern you want. As a default, our dowel will be 8 millimeters, drilled 12 millimeters deep. But as you'll find, we'll go take a look at the connector tab, which is where we'll start defining our Rayfix connector. And looking for a closets 19 definition, we don't find one, so we're going to use the default with Rayfix. And we've overridden the diameter to be 5 millimeters. So anytime we use a Rayfix connector, it will change to a 5 millimeter diameter hole. All of the other information is defaulted back to what we've defined here, a 12 millimeter depth, etc. And again, we can override it on the Connector Systems tab. The purpose of the Connector Systems tab is to tell CabinetSense what side of the part you want to machine the connector from. So for example, our fixed shelves, we will machine the hole from the bottom side of the shelf. And so you can change it to be whatever you want. That's part one. The second part is defining the actual machining for one Rayfix. So we'll go down. We're looking here at the top is a Cabineo, the name of the connector. The connector system, which is a reference back to the Connector Systems tab, is Cabineo. So I'm going to simply scroll through the record set looking for Rayfix connector system. And here's one. Now, Rayfix has a collar, or the ones we're using anyways. So they are machined for different thicknesses of material. So here is a 16 millimeter Rayfix connector, and it can be used on 16 millimeter or thicker materials. CabinetSense will look for the one that is directly smaller or equals to the material thickness that you're using. So if I scroll one more, here is a 19 millimeter thick material. And if you remember, our model example is using 3/4 inch material, which is roughly 19.1 millimeters. So it will choose this Rayfix connector, and it will position it as if it's a 19 millimeter thick material. And it does that because of this thickness sensitive attribute. Okay, we have a specific definition for closets 19, and it's a one hole Rayfix connector, diameter 20 millimeters, drilled 14.2 millimeters deep, with the center point 9.5 millimeters in from the edge. And I should mention, you can mix and match imperial and metric measure in any of the machining fields. So if I wanted to, for example, use 5/8, I can simply type 6.625, without any letters after it. So this will signify its inches, and an mm signifies its millimeters. Okay, that defines our connector. So anytime we want a connector, this is what we're going to machine, and the pattern tells us where to place it. Let me just hide the drawers and the doors. Turn off hidden geometry, and let's go ahead and machine it, or do a preview. Turning on X-ray mode, there's our Rayfix connector. And again, using the same hole as our line boring, front and back. And again, with 32mm system turned on, we're only able to move in 32mm increments. Let's take a look at our doors. So you can see our hinge cups, and on our carcass, we're not drilling any extra holes, so again, using the line boring holes. So let's go and take a look at our machining database to see how we accomplish this. We'll go to hinging, and here are specifications for the two closet templates. So here is our Closets 19 template. Our bottom hinge clip and bottom hinge is referenced from 78.5 millimeters up from the bottom of the door. Our top position is the top of the door minus 78.5 millimeters. And it's these settings, the 78.5, that is how we control exactly where we're going to line up our hinge clips. So in this case, I'm going to change this, and I'm going to make it 75 millimeters. Top and bottom. We'll go ahead and refresh our pStore database. And let's go back. I'll re-preview with the changes we made. And now we have our holes no longer lining up. And so all I did was I used the standard setup I have in our sample database for our doors. And then I simply measured the difference. And 3.5 millimeters. And I did the same for the bottom. And again, it was 3.5 millimeters. So that's simply went back into our database and started working with the offsets to come back to what we need to make them use the line boring setup. And again, because Cabinet Sense is using the fixed shelf to reference the doors, if I move the fixed shelf only in increments of 32, we know that our hinge clips will always work because we're always 32 millimeters on our line boring. That's how easy it is to do the doors. Slightly more complicated are the drawer system. And then our sample database, I am using an Accuride slide. And let's take a look at it. I will go down to the drawer box. And there's the name of our slide. It's an Accuride slide. In this case, Cabinet Sense has chosen a 10-inch slide to go into this cabinet. That was the largest one that could fit. So what we'll do is we'll go take a look at the machining information for an Accuride 10-inch slide. Go into our drawer system, and let's take a look at slides. Here is an Accuride 301, and I'm just going to scroll through. There is an Accuride slide. This is a 10-inch slide, which is the one we are using. And so our hole position is 37 millimeters from the front, again, lines up with our line boring. And our second hole is actually 37 plus 128, which is not part of the line boring setup. So if we take a look, I'll remove the drawer so we can see where our holes are. We have this one, 37 in, and this one would be 37 plus 128. So just taking that guy, going to here, there's our 128. So Cabinet Sense has drilled an extra hole. So if our slides could work, we could have specified this hole, and again, we wouldn't have drilled any extra hole. So it really depends on what slide you're using and if you can accomplish using all the holes in your line boring setup. That is our front to back drilling. Now let's worry about the top to bottom. So what I did with an Accuride slide, you have two holes to drill. You've got the holes on the carcass and you have the holes in the drawer box. So going back to the database, there's a mechanism in Cabinet Sense called slide pairing. And the purpose of this is to move the vertical position of the holes on the carcass and the holes on the drawer box in sync so that they're always lined up. So we've got a definition for closets 19, and I've set the hole to be 64 millimeters up from the bottom of the drawer box minus a 17.5. And the 64 was a multiple of 32, and I said that in our closet system, we won't be drilling or machining boxes that are more than, let's say 100, 120 millimeters high. So I'm safe to position at 64 millimeters up from the bottom, and then I subtracted 17.5. And just like the door, it is this one that I used to move the holes up or down until it matched the line boring. So if I simply get rid of it, refresh our PStore database, oops, I forgot to refresh. Let's do that. So now our drawer slide holes are not lining up at all with our line boring. And again, the same with the doors. I just simply went in and move it down 17.5. And again, the same as with our doors, all the lineup for our drawer slides are based on our fixed shelves and stretchers. So again, moving up and down in 32 millimeter increments, everything will always line up to any given set of holes. Hi, this is an update to the machining video. After the video was made, we came across several scenarios where the machining just wasn't holding up well enough for our closets. We found that closets with backs, closets without backs, variations in actual material versus what we planned or what we designed the closets for, all caused hole positions to vary and become out of place. And so here's our solution to make this seamless and easy for you to use. We have a nominal thickness now, and it serves several purposes. You design the closets with nominal thickness in mind, meaning I want to design a closet with 3/4 inch material. But when you actually get the material, it might be slightly more or slightly less than what you had designed it for. Also, if you're using a camlock type of a connector, such as a Rayfix, they're specifically designed for a certain thickness or nominal thickness of material. And so now we've changed Cabinet Sense to make nominal thickness really key when you're doing closet designs. So we'll walk you through the changes we've made and how that makes your life a lot easier when you're doing closets. And when I say closet systems, what I should really be saying is anytime I do a design where I want 32 millimeter system turned on, and I want to use line boring as the holes to support my cam lock connectors. So with that in mind, let's look at some of the key pieces. We have 19 millimeters as our nominal thickness. And one of the key things is, like I said, when you're using a cam lock connector, you must have a cam lock that is exactly for that nominal thickness. Going to our machining database, I have a Rayfix connector that is specifically designed for the 19 millimeters. So I'm going to use this. Just an aside, I also have a Rayfix connector specifically designed for 16 millimeter. The normal cabinet sense rule is that I'm allowed to use a 16 millimeter connector on material thicknesses of 16 millimeter or greater, but not on material thicknesses less than 16 millimeter. When you have nominal thickness and build 32 on, you can use thinner material on the 16 millimeter connector. That way you don't have to worry about what the real material thickness is compared to what you're designing the closet system for. Okay, let's go back to our closet and do a machining or preview machining. All of our holes are lining up. Let's go back, take a look at our project. So right now we've got 19 millimeter nominal thickness. Our actual thickness is 3/4 of an inch, which is slightly more than 19. Let's do the reverse. Let's go back and we'll use slightly less than 3/4 of an inch. And we'll let Cabinet Sense change all of the bays for us. Okay, so now we've got a thinner material than what the nominal thickness is for. And our holes all still line up. And in fact, if I went back to the project and changed this nominal thickness to 16 millimeters, even though I'm using way thicker material, Cabinet Sense is still going to adjust accordingly and everything will still line up. So all of our holes are still lining up. And let's just take a look at where things have been positioned. Taking from the bottom of the shelf, it's 8 millimeters up, which is half the thickness of our 16 millimeter connector. And going from the top, it's the difference, 10.9 odd millimeters. So again, the Rayfix connector has been positioned properly for our, even though we're using thicker material. Let's put backs on the cabinet. And a lot of times you can run into a scenario where you've got a full back on one bay and a partial back on the other. And a lot of times you want to share the through holes for that back Rayfix. So have a common connector for the two Rayfixes. And with the build overrides turned on, when we are processing a back, we'll just go into the back and set it up, let's say 36 inches. With the build 32 overrides on, Cabinet Sense is still going to machine it as if it's a full panel, calculate the positions as if it's a full panel, and allowing you to share that common hole. Let's go back and turn off the overrides. Turn off the overrides on line boring. And take a look at what will happen if you don't allow Cabinet Sense to work with the nominal thickness for you. Extra holes. Noticing our hole positions don't line up for our Rayfix connector. If we take a look at the back, the holes now don't have through holes except for the very top. The very top of the cabinet is using a different hole position, just not exactly what we want. So having the overrides turned on just, again, makes your life that much more easier. And that wraps up this segment on working with the machining database. You should have enough information now to go ahead and start creating your own strategy for designing your closets. Thank you very much for watching.